Hey everyone, my name is Jo Franchetti and I'm super excited to talk to you today. I hope you've all had a fantastic conference so far. I'm a developer advocate at Ably, which means that I get to make all kinds of fun projects to show off what Ably can do. And we're a platform that provides reliable and pleasant to use messaging infrastructure that allows developers like you to build apps that use real-time data. So I make all kinds of fun things, like this web app that live tracks all of the buses that are currently driving in Connecticut in the USA, or this peer-to-peer web-based multiplayer game called It, which I made last year, which is very fun. And one of my favorite things to make is wearable technology, specifically things with lots of lights on that can connect to the internet, because I like to be sparkly. And I started making wearable projects a couple of years ago. My first one was a wearable light up wedding dress. And when I started building it, I had no real clue about what I was doing. And I made quite a few silly mistakes around choices of hardware, how to put them all together. And so my hope for this talk is to give you a little bit of direction if you're looking to get into hardware projects or wearable projects, to get you over that initial hurdle of hardware is scary. So this time I wanted to make something that we all could interact with together, because I don't know about you, but with all the social distancing and the lockdowns, I've been really missing having my friends and colleagues and just other humans around me recently. So I thought, what if I make a wearable that lets my friends change the color of what I'm wearing in real time? I'd be able to see the changes that they were making as they were happening. Kind of like a multiplayer version of MS Paint, but wearable. So in order to realize this dream, we're going to need a few things. Firstly, we're going to need an array of lights, which is going to be able to change color. We will need a microprocessor, which is going to control the lights. We will need an app where our friends can actually set the colors that the lights are going to change. And we need a method of sending messages to and from the app to the microprocessor. So let's start with the array of lights. It's going to be a 16 by 16 grid of LEDs. And the LEDs that I used in this project are called Addressable Rgb Leds. Addressable means that we can target each one individually. They each have an address. And RGB means that we can set it to basically any color that you can think of, using a similar color value to that which you're probably used to from CSS. And the product name of these, if you're looking to buy them, is Neopixels. And they come on these ribbon strips, which makes working with them really nice and easy, because it means that you don't have to solder individual LEDs. It also makes them nicely robust for a wearable. Because you've got fewer solder points, means there are fewer points of weakness. They're quite nice and flexible. These strips are also great because, as you can see in this picture, they have very clear labeling for which lines are carrying your data, which is the D line there, which is carrying the power, which is the 5+ line there, and which is carrying the ground. So you are less likely to make a mistake when you're connecting them up. And so what I did to keep the strips safe, because you're going to be wearing them, you're going to be moving around and bending them, you don't want to bash them too often, I sewed 2 pieces of fabric together to make a pocket and insert each strip into it, which looked like this. So if you can imagine sewing across each of those lines, and then you can slide each strip into them. I'm not actually very good at sewing, so when I created it, it actually looked a little bit more messy, but this is what we ended up with. And so then you insert the strips into each line and solder up the ends. And what you have to do here is make sure that your data line is connected to your data line, your power line is connected to your power line, and your ground line is connected to your ground line. And you can buy soldering iron and solder from Amazon for about £30. And what I've used here is called single core copper wire. And what that means is it's just got one thick copper core in the middle, which makes it nice and easy to solder. You don't have to worry about your ends fraying. I recommend also getting a heat-proof silicone mat to put on your desk to keep it safe when you're soldering. And incidentally, these double up as excellent baking sheets for making cookies. And there are lots of tutorial videos on YouTube for how to solder, so I'm not going to go into it here. Suffice to say that once you give it a try, it isn't as scary as it seems. And once you've had a few goes at practicing, you'll get the hang of it very quickly. So once both ends are soldered together, we have a finished, flexible LED array, which looks like this. And I have a video here to show you just how flexible it is and how cool it looks when it's illuminated. So now we have an array of LEDs, we need a way to actually control what colors are going to be sent to it. And the microprocessor is useful here as they can do enough calculations to control the lights, but they're nice and small so they can be easily hidden in a wearable. And I opted for this one, which is called the Adafruit Feather Huzzah. And I like this one because it's super small. It's 5 centimeters by 2 centimeters. It also has Wi-Fi on the board, which means I don't need to connect any extra Wi-Fi modules. I can just directly connect it to the internet, and it's not too expensive. They cost about £25 each. That's approximately $25. The Huzzah is low power, so it can take power from a USB battery or from the USB port on your computer. And it runs C and C++ code out of the box, which you will write for it using the Arduino Ide software. The Arduino Ide is great because it comes with all the libraries and the sample code that you need to get up and running with the board quickly. And the code for the Huzzah looks a little bit like this. So here what I've done on this first line, I have included the library for the Neopixels. Then I have included the library for the Wi-Fi. Then on this line here, I have defined pin number 4 and defined the number of lights that are in my array, which is 256, because that's 16 by 16. You have to be careful when you're telling it what kind of lights you're using. So here you can see what I've done. I've set Neopixels strip, and then I've told it to use the number of lights, the pin, and Neo RGB, because I'm using RGB pixels. You can also buy RGBW pixels, so just be careful to make sure that you're using the correct ones. Then we are setting up the strip for use, and we are going to then loop through each of the lights on the array and set the pixel color using strip.color. And what you see here is 255, 255, 255, which I'm sure many of you will recognize is white. So what we're doing, we're looping through every single number of lights from 0 to 255 and setting them all to white. And then what strip.show does is it's going to actually turn the lights on. Just to show you this on the board, pin 4 is this pin here. The USB power that we're going to connect up from the battery is going to come out of the board there. So the power will go into this USB socket at the bottom and then come out of this USB pin here. Then we've got our ground on the other side. So now we have a display and we have a way of controlling it. But we need to tell the controllers what colors that we're going to set. And being a web developer, I, of course, opted to build a web app. If you want to see the code for both the web app and the code that's running on the Arduino, you can see it at this GitHub link right here. Yeah, feel free to check it out at your leisure. Feel free to take it, use it in your own projects. If you do turn it into something, please do tweet it at me. I would love to see it. And the app that I built looks like this. And it's got some buttons at the top where the user can pick a color. And it's got an SVG array of squares that represent the pixels in the array. And each square in the SVG has its own ID with a number. So the first pixel on the top left is 0, then we've got the one to the right of that is 1, the right of that is 2, etc., etc., etc. And once a color in a square has been selected by the user, the app updates the fill color of that square to match the selected color from the palette. But we also want it to light up the correct LED on the t-shirt, not just the squares in the app. And we can do this using a real-time messaging service to send messages containing the color and the pixel number from the app to the board on the t-shirt. And in this case, of course, I'm going to use Ably to do this, because what it does is it allows me to use something called PubSub to create a channel. And then what I will do is I will publish messages on that channel from the app as they happen. The microcontroller that's attached to the t-shirt will then subscribe to this channel and get those messages as they are sent. We can also subscribe every other user in the app to this channel so that everybody who's looking at the app can see everybody else's drawings exactly as they happen. Every time a user changes a pixel, a message is published to the channel and all of the subscribers will receive it. And you can have a look at the app if you go to this URL here, and you can start changing the pixels. Now, because we're doing a recording here, sadly, as you're changing the pixels, you won't be able to see them light up on my t-shirt, but you will be able to see them if you share the app between two different tabs, for example, or you send the link to a friend, you'll be able to draw little pictures to each other. So the app is built with Node and Express, and on the front end, I used Ably's messaging platform to set me up with a channel. Then I used their JavaScript SDK to manage the publishing and subscribing to messages on this channel. I see some people are actually playing with the lights. That's brilliant. So what I'm doing in this code here is, first of all, I'm making a new instance of the Ably real-time library. Then I'm going to create and connect to a channel called t-shirt. And as I mentioned earlier, the cool thing about PubSub is that all the other users of the web app can also subscribe to these messages so that their clients can update them when other people paint cooperatively. So everybody who's using this at the moment will see everybody else's drawings. And we're using the Ably SDK. It comes with this create token request feature to authenticate so that we can be allowed to connect to the data stream. And on the back end, what's happening is our Node server is going to require the Ably Promises SDK. It's going to do the authentication, and then it's going to create a token request object using tokens instead of putting the API key directly into the URL, which keeps our API keys safe from misuse. So as an aside, as I mentioned, all of this code is already on GitHub. So if you do want to have a look at it, I'm not going to be able to go through it super thoroughly during this talk, otherwise we'd be here all day. So now that we've established a connection, so we've done our channel.attach and we've connected to our Ably channel called t-shirt, we can publish a message to that channel when somebody clicks on a square. So that's what we're doing here. We're going to add an event listener for a click on a square, which is our pixel. And when clicked, it's going to get the number of the square that was clicked, and it's going to change the fill of the square. So for those of you who aren't used to SVG, fill is exactly the same as CSS background color. And then what it's going to do is it's going to publish both the square number and the color value which was selected to the t-shirt channel. So you can see that happening here in the code. We are getting the ID, we are getting the fill, and then we are publishing those two values to a message called t-shirt. And it would look like this. So what we've got here is we've clicked square number 1 and we've set it to purple, which has a hex value of AAOOFF. And we want the web app to display the pixels which are clicked by other users. So we need to subscribe to messages too. And as such, we're going to subscribe to the channel as well as publish to it to get the updated pixel values along with an optional reset in case I want to clear the t-shirt picture in case somebody decides to draw something not safe for work on it, which would be a skill in 16 by 16 pixels, but I wouldn't put it past people. So what we've got here is we've got an optional single pixel, which is going to set up the square number of the color value and apply the supplied fill color to the relevant square. We've got reset display, which is going to just fill all of the squares to black. And so now our app can update its own and other people's displays. But we need a way to get the data to the Hussar, because at the moment we're all still in the web app. And you're probably familiar with HTTP, which is the protocol that browsers use to request web pages. And HTTP is a protocol, and the word protocol just means the way that two things talk to each other. And HTTP is great. It powers websites and APIs and is built to be descriptive and flexible. And it can be used for IoT connections, but it's not very lightweight and it's not terribly fast. And another problem with HTTP is that it's pull only. The device has to constantly reconnect and ask, are there any updates? How about now? Anything now? Which is not only really data and time consuming, but also can consume quite a lot of power. And on a low power IoT device, we don't have much memory, we don't have much bandwidth, we don't have much power. So we need protocols that are designed to be small and fast. And MQTT is that protocol. It stands for Message Queuing Telemetry Transport, and it's a connectivity protocol which was designed to be extremely lightweight. Connecting to a server only takes about 180 bytes, and the device stays connected the entire time. Data is published when it's pushed from the device to the server, and the device subscribes to data being pushed from the server. Because the size of the data being sent over MQTT is small by design, messages can be sent really quickly, making the hardware super responsive, which makes it feasible for us to change the lights on the t-shirt basically as people are clicking the pixels on their screen. And in order to use MQTT, you are going to need an MQTT broker. And a broker is the service that devices to connect to using the MQTT protocol in order to listen for messages. And it keeps track of the clients that are connected and the topics that they are subscribed to, and it forwards any messages to the correct subscribers. In this case, I'm using mqtt.ably.io as my broker. And the awesome thing about Ably is that because we're already using the JavaScript SDK and sending messages through that, they are automatically sent out via MQTT for free. Ably just does this by default. It requires no extra setup by me, so for me this is a big win. So let's talk about how we connect the microcontroller to the MQTT broker. Again, we're going to be using the Arduino IDE, and with the Adafruit Feather Hussar, this is nice and straightforward. So we're going to install the IDE, and there's a really nice clear walkthrough on how to set it up on the Adafruit website. If you go to using Arduino IDE on the Adafruit website, you'll find it there. The IDE also comes with a whole load of example code for beginners and all of the libraries that we're going to need in order to get this set up. So the first thing we're going to do is include the Wi-Fi client secure library and the MQTT library. They come with the IDE. Then we're going to set up a config, which is what we're going to need, all the credentials that we're going to need in order to connect to Wi-Fi and then connect to MQTT. So what I've set up here is SSID name and Wi-Fi password. So at the moment I'm using a hotspot on my phone for the t-shirt to connect to. So this would be the SSID of my hotspot on my phone and my password that I set up there. Then I'm setting up the MQTT broker host name, which is mqtt.ably.io. We're setting the port that this is going to use, which is 8883. And the username and password for our credentials to connect to that. And these are going to be the two halves of your Ably API key, which you will get when you set up your Ably account. And then we've got this scary looking blob of hex code here, which is called a thumbprint or a fingerprint, depending on which browser you're using. And what this is this is the SSL certificate from mqtt.ably.io. And we need this, the Wi-Fi client secure library needs this in order to connect to MQTT. If we don't provide this, the connection will fail. And you can find this if you right click on the little lock icon in your browser URL bar, if you right click on there and click for details, you can find out your fingerprints for your broker. So finally, we need to then set the channel name that we want the board to subscribe to, which is going to be T-shirt, which is what we set earlier. And similar to what we did for the web app, we need the Feather Hussar to connect to the Ably Mqtt server and subscribe to the channel. The board isn't going to be pushing anything, it's just subscribing at this point. So we create a new instance of the Wi-Fi secure client and the Mqtt client. And while we're connected to the Wi-Fi, the secure client lets Mqtt use SSL to connect to our Ably channel using the credentials that we just set in the config. And when a message is received in onMessage, we can process it. So let's say that we received the example message that we got from earlier. So this one here, number 1 and purple. First thing we're going to do is split the data at the hash so that we can separate it into a number and a color. And then we're going to convert that hex value into RGB. And then we are going to send the pixel number and the RGB value to the lights to update. So now the eagle-eyed amongst you may have spotted a little, we could call it a mistake, we could call it a choice that I made when wiring up the lights. So let's take a look at the array of squares from the web app. So I gave each of the squares a number to represent the number of the pixel in my LED array, like this. So you can see they're each numbered from left to right, and this is how arrays work. 1, 2, 3, 4, 5, 6, 7, down all the way down to 16. Then we move on to the next row, 17 to 32. But this isn't how I soldered my lights together. I wanted to keep my wires nice and neat, so I soldered these nice little jumps at either end. And if I were to represent the way that the numbers are moving through these lights, my array ends up now looking more like this. Which isn't ideal. So I've affectionately termed this method of enumeration snake mode, which means that I essentially have to reverse every other line of the array. Oops. So what I did was on the board, I made a method which checks whether the position needs to be reversed. So here we have the X and the Y values to work out where the pixel should actually go. So to calculate which row the pixel is on, we divide the pixel number by 16. Then we use modulo 2 to work out whether we're on an odd row or an even row. We get either 1 or 0 for odd or even. And then we can work out how many pixels came in all of the rows before that pixel. So if it's an odd row, then we minus the X position from 15 to get its reversed position and add that chunk to the number of pixels that came before it in order to calculate exactly which position should show on the t-shirt. Now, I have been told that this is actually how many pixel arrays work for the exact same reasons that I made it this way. It means you have much fewer trailing wires. If I was going to try and wire it up exactly the same way that we read an array, I'd end up needing a row of trailing wires to bring that connection all the way back to this end, which is not very good for a wearable. So now we have a wearable display. We have a method of controlling it with the microprocessor just here, and we have an app which we can use to select colors for the t-shirt, and we have a method of sending those colors between the app and the t-shirt. So now, in case you haven't already had a go, it is time for more demos. So I'm not sure if anybody is actually left drawing on the app. Let's clear it now. And maybe I can show you this happening live myself. So let's try this. So you might be able to see my pixels showing up on the t-shirt there. Just about. I hope that this talk has demystified IoT and hardware, and that it encourages you to give hardware a try, because it's really not as difficult as it seems, and you can end up with something awesome and fun. Thank you so much for listening. This is my GitHub project if you want to see the code. If you do make something with it, do tweet me at thisisjoefrank and at ablyrealtime to show me what it is that you made. Thank you so much.